There are three problems that Vellum really help us with. Number one is of this, how do we balance like AI applications with security and privacy? We have a lot of customers giving us security questionnaires actually around our AI practice and asking us if we use the data for like training and like how long do we store the data, etc. And then number two, of course, is that as AI engineers, we want to focus more on the development of AI pipelines and less on the actual like infrastructure and hosting of them. And so we'll show how Vellum addresses that. And the third one here is it'll be more clear in the next slide, I think, but the lack of iterative AI development tooling. Sorry, in the iterative portion will be in the following slide. And so the first portion here is the AI privacy and security layer. And so we have actually the Drata application is unique because we have one database for every customer. And so we have 7,000 customers, we have 7,000 databases. And they are actually like physically separated. And so we needed to maintain separation on the Vellum side. So Vellum hosts our document storage for us as well. And we needed to host many vector databases, one for each. Actually, we have 3 to 4 for each customer. It depends like what application they're using. But so we have 21,000 or 28,000 vector databases. And we keep those, pieces of data logically separated. So that is a very big thing for us that Vellum provides this allowing us to separate the data like that. And so the way it works is when tenant A actually makes a change to their database, we capture that change with decodable and it gets sent to the tenant A document index responsible for questionnaire automation. So this is the knowledge base, just to be clear. The second piece is this iterative process. And so what I'll mention is that as a data scientist, I was a data scientist before becoming an AI engineer. And normally as a data scientist, you work with, domain expert to build a machine learning model. You go back and forth. You say, oh, what are the like important predictors do you think for this problem? And then you try to code those in, you try to model it. I think AI is actually very similar, right? Because like, we are a compliance, we're a startup in the compliance domain, but what was my compliance knowledge coming in? Not much, right? And so we had to work with like internal people, internal stakeholders who know this like compliance industry more. And so for us, I'll mention that it's actually our product manager who often goes in here and actually evaluates pipelines himself. We also do some batch evaluations, show it to our compliance team just to get a thumbs up. But in terms of the iteration, this is what Anita was talking about earlier, where Vellum has this drag and drop workflow builder. So you can chain together like a prompt to like code and then chain together to like another prompt and so on. And so because I made the version 1 of security questionnaire automation, like in pure Python, using just, I guess LLM calls directly and like a vector storage. The advantage of using something like Vellum is that it can handle that complexity for you of like, for example, if you have like two paths, like you want to, like for us in questionnaire automation, when a question comes in, we actually fork and we actually in one path, we actually answer the question using only uploaded questionnaires. And then in the other one, we answer the question only using the Drata information. And then we chain these together and we have a reasoning call in the middle to actually like identify which one is the better answer. And then we send the better answer. And so we also have like other pieces of logic here, like in terms of the Drata objects, which ones are the best ones to answer a question. And so this is not the questionnaire automation workflow. I'm actually showing a simpler one here, a less sensitive one too. But I can tell you that the number of steps to answer a question is actually, it's not just a simple like RAG where it's like retrieve reasoning and then we send out an answer. What we found in our experimentation is that sometimes we have too much data and we're actually missing the correct answer when we answer a question. And so a lot of our experimentation was how do we pare down all this data that we have into like more relevant pieces and then only use that. And that actually increased performance for us. And so for us, like it's, this visual editor allows us to work together with like less technical stakeholders and iterate on the solution, right? And so this drastically sped up our iteration process. And then, as Anita mentioned, once we have this pipeline set up, we have to evaluate like, okay, what's the accuracy here? How well is it doing? And so what we did was we got not this is not exactly the screenshot here, but what we did was we got a lot of the questionnaires that the Drata team had to fill out, and we used those as our test data. And so we had something like 100 questions, and then we added them to our test suite, and then we used like a LLM as judge to evaluate the answer quality, and also if it was like hallucinating. And so whenever we actually make a change to this pipeline, we actually run the whole test suite again. We make sure performance doesn't degrade. And another thing that we also do is we run this evaluation suite using the Vellum SDK. So we attach it as an Airflow nightly job. And so we're always monitoring the quality of our AI responses. This is just in case like, LLM quality like silently degrades or something, we're gonna catch those events. And then the last piece of why these evaluations are big for us is if a customer comes in and they say, look at this question I asked, why is it answering incorrectly? Then we actually, if we say, okay, yeah, we were wrong there, we add that to our evaluation suite. Then we actually iterate again on our workflow and we try to get a good quality answer as long as the other ones don't degrade, right? We need to make sure we don't degrade on the existing evaluations. And so evaluations is such a big part for continuously improving these pipelines. And it can even be evaluations like, oh, the output has to be JSON and things like just more business rules also. And so we use the evaluation suite in all of our pipelines inside Vellum also have corresponding evaluation suites attached to them. And then as Anita mentioned, another thing that Vellum gives is like you have this like one-click deploy. And so when you iterate on a workflow, you did your drag and drop, and maybe you did your evaluation, or maybe not sometimes, but normally you do your evaluation and you get a good performance, you can just one-click deploy. And so here, what I'm showing you is like the historical invocations of that pipeline running in production. And so what happens is we deploy that, and there's an API endpoint we can hit to trigger that workflow. And then that API endpoint we hook into the Drata application. So from the Drata application, a user clicks a button, or in our case, uploads a questionnaire, right? And then it automatically hits those API endpoints to Vellum to actually execute our AI pipelines and answer that questionnaire. And then for each one of these, I don't have a specific image for this, but for each one of these executions, you can actually drill down into the graph of that execution, and you can see all of the relevant inputs and outputs for each node in the graph. And so the debuggability and the observability is like very, very high in Vellum. And so these are the things that if I coded the V1 of this application in Python from scratch, and we had something running, we had search, we had like API calls to LLMs, but we didn't have like this level of like granular observability. We didn't have like this level of logging, and also like this like continuous monitoring and like evaluation. And so it's easy to get, I guess, an AI application out these days, but it's hard to get it like in that like enterprise grade level. And you need to a lot of like the services that Vellum provides really helps for this, because really helps you get to that enterprise level because you have so much more observability and it's an insight into what's happening in your AI systems. And so just to recap here, we were able to roll out this security questionnaire application within 60 days inside Drata, even considering all of the compliance requirements, considering the latency. And so our stack here was from the raw data of our users, we used decodable to Java. With the Java Flink SDK, we were able to pipe them into Vellum, into our document indexes. And then we iterate with the AI workflows that use the data that has been indexed inside Vellum. Vellum uses VB8. And then From there, once we were ready to deploy, it just became a one-click deploy. And then our application development team just now hits that endpoint. And whenever, we launch it in a beta phase, and then whenever somebody complains about like performance, or whenever a user sees a bug, we go into this Vellum screen and we just like open that execution, add it to our evaluation suite, run the evals again just to ensure performance is good, and then we push those changes out. And so Vellum also handles that release cycle for us. And so the AI release cycle needs a more frequent cadence than the application development cycle, because we need that autonomy to be able to push out even small changes like instantly to improve the AI system. And so what Vellum and also what Decodable does is they allow our AI team to operate independently and iterate independently of those other teams inside Drata. And this allowed us to move a lot faster as a whole when developing AI applications.